Hello. Hi, everyone. Well, I must say that this is the first time I presented in a cinema theater like this, like kind of cute. So yeah, welcome to my talk. And today we're going to talk about whether or not we are doing React wrongly. And the first answer is yes. Anyway, we're doing React wrongly, but why? So a little bit about myself. My name is Shavin. I'm a senior software engineer at Microsoft, and I'm not building Windows. I'm working for Industrial AI, which we are the group that leverage different AI technologies to build solution from end to end, solution and application for industrial partner and customer. I've been in the web industry for more than 10 years. So I started at front end, and recently I moved to more full stack and more like doing with C# and not just JavaScript and so on. I also write books, so if you want to learn another progressive and faster framework, yeah, faster than React, but we don't say that here. Anyway, if you want to learn a new framework with TypeScript, check out my book at Learning View. I also in social media at Shavin. And you can also follow my blog at myshavin.com. I'm a Cloud Engineer Ambassador, a Google Developer Expert on Web Technologies, and an organizer for Vue.js Israel. Okay. And first and foremost, disclaimer, this is not a hate React talk. Though I just wrote a book about Vue, it doesn't mean that I want to talk about how much I hate React, though I work with React. So anyway, this is just a talk about how we can improve our way of writing code in React to make it better. So, but first and foremost, let's do a small recap. React have just celebrated its 10 years last year, 10-year birthday last year, and it's been 11 years today. So that's quite a journey, right? And among these 10 years, we have several releases, a lot of big releases. I like to point out some very significant release. We started with class component, and then React entered Swiss 16, which become a teenagers with functional component with hooks. Everyone was so happy, it's so sweet. Everyone started writing component, functional component with hooks everywhere. And then last year, React released another version. I like to call it the grown-up version, or 18 plus. We call it server components. Whether or not the server component is a good release or not, well, I leave it for another speaker to explain about it. I'm not touching it. But anyway, and this year sometimes we're going to have another version of React. Yay, React 19, more grown up. And it's already in the state of release candidate, and it's expected to have more performance and improvement here. But that's about React. All the features is very cool, right? What actually excites me the most during these 10 years is that finally we have a proper documentation page that dedicates to React, which launched last year. So for the last 10 years, we kind of follow the documentation that we don't really know what's written in there. And finally, they say, okay, it's time for us to have a proper documentation that teach everyone how to use hooks proper from the beginning. And everything starts with tutorial using functional component. Wow, it's having an improvement. And I must say, the moment I saw that, I was so happy and relieved, because hooks, especially useEffect, have been there. So many fragmentations, so many content, so many billboards that talk about what is the best practice. Every tutorial on YouTube, you can go there and you can take a look. Every tutorial start with how do you use effect. Good or not good, we always debate on that. We always like fighting with each other to see whether this is a good approach, what is the right pattern to use it. But again, in this talk, I'm not discussing about useEffect because that's a bit ongoing debate. But we know we have useEffect everywhere. And in React 19, even with the new documentation where we expected to have useEffect written correctly, how to use it and reduce the fragmentations, we still have some document that is official document that use useEffect wrongly. This is from the official documentations for Azure Static Web App. Yes, from Microsoft. Yeah, shame on us. I found this in 2022, and it still haven't fixed in May 2024 in the latest update. So if you copy this code in your sample application for Azure Static Web App and trying to run it, your app will crash because it's run infinity, because the useEffect here doesn't have any dependency list. And this is official documentations. So we're still doing it wrong. And guess what? In React 19, we are expecting more and more new hooks. It's like we never have enough hooks, so now we have more hooks. We have actions, we have form status, we have something very optimistic, like use optimistic. I feel very, very, very happy to see this because I have no idea what it does, except for making me optimistic. And we have use. And that means we have really in trouble with use hook. We have hooks everywhere. But let us take a step back and not get into how many hooks and what hooks good for which case. I want to talk to you about something I saw over my developer experience, that whenever I go to GitHub Rebel or even production code in closed source code, I saw a lot of useCallback or useMemo. So here you can see useCallback is wrapped everywhere. Every function is wrapped useCallback. So the question here is, I always ask myself in every code review, like always PR, I always ask myself and always ask my teammates. And recently I found also Reddit, someone actually asked the same question like I asked. Why are we using useCallback to wrap a function everywhere? By the way, if you go to the answer, it's pretty funny to take a look. And at this point, I feel like I'm a fish on the hook because no one gave me the correct answer here. And if this is what React team have been trying to do when they name the features hooks, they got me at least. Because the more I use hook, the more you use callback, the more I look at the PR, I feel like I'm a fish in the hook, stuck. So now let's see how we can discover on the myth around these hooks, performance, and usage, okay? So the first answer, the common answer that I got from my teammates and even on the Reddit discussion to the question, why are we using all this useCallback and useMemo, is because it's better safe than sorry. You don't really know whether we need it or not, but it's always good to memorize performance, right? It's always good because the performance optimization, one part of it is memorizations. So we cannot go wrong with doing that. Is it? So let's take a look about two hooks today, useMemo and useCallback. So let's start with useMemo. So useMemo is the hook that allow you to catch the result of calculations between renders, which means you can just wrap the functions that return a value with useMemo, pass it some dependency, and it will help you React would skip expensive calculations during render and make sure that it will not try to re-render in every update, not try to re-render something that was not changed before. And in strict mode, it runs twice. Though I don't know why it runs twice. According to the team, it says that if it runs once, it should work the second time. And this is like a security check that they provide for developer. It needed? I don't know. You tell me. So the thing is, among all of these definitions, there's one question that bothers me. How much is considered expensive calculations? We talk about expensive. Expensive is a very related concept. With a person, expensive can be €5. With another one, €5 can also be not expensive at all. It's really depend on the application, depend on the use case, depend on developer, what she care or not care to define expensive. So how are we going to decide what is the standard for the expensive calculation? So for that understanding, I'm doing a very small comparison between two approaches. One is the implementation of a component with useMemo, and the other one is without useMemo. So with useMemo, I'm going to, for both cases, I'm going to render a list of items, call it movies, for example, that only have a title and a status, whether it's favorite by user or not. Okay? So the list of movies are randomly generated, but first start with 100 items in the array. And then the component is the list item component that I have a local state. I keep a list of favorite items, and I have a button called, I have a function called onFavorite, and it would change whether to remove an item from the favorite list or to add an item to a favorite list. And of course, I need to implement the list item, which is using useMemo or not, and render the component. Okay. So what I'm going to do here, after I implement the functions, I will do 6 clicks. 1, 2, 3 to enable the favorite, and then 1, 2, 3 to disable the favorite of the 3 items in the list. That's it. 6 render. Okay. So without useMemo, you already know. With useMemo, all I need to do is wrap it. Sorry. Not working. Wow, stop. 1 second. Oh, it's not respond at all. Just just 1 second. Wow. This is the first time my Mac stopped working on me. So maybe it doesn't like it when I do the comparison for its hook. So let me just restart. Bear with me 1 moment. I think last time when I have this problem twice whenever I reach to this slide. So, okay. Meanwhile, how many people here are using React? Oh, that's good. How many people here using Vue? 2, yay, Vue rocks. How many people are using Angular? And, okay. Also 2, that's great. And how many people are using jQuery? Ah, wow. You really using jQuery nowadays? 15 years ago, okay. I'm still using jQuery sometimes though. And I kind of feel a bit like we would never get rid of jQuery somehow. So. Anyway, so how many years have, for people who using React here, how many years you've been working with React? Don't tell me 20 years because that's not possible. Okay, here you go. Let's try. I'm just close it. No. Oh God. Force quit. 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 Wait, nothing else. Okay, quit. And let's stop with this. And okay. Great. We are in this slide. Yes, so here, great. So now we, for which useMemo. Oh, wait, display. Wait, let me just, maybe it just gave me the wrong one. Display. It's mirror. Okay, great. Okay, So here with useMemo, you all know that. Anyone that use React will know that we are wrapping the functions with the useMemo functions, with the useMemo, and pass favorite items at the dependency list. Okay? And so now here's come the quiz for you. Which one of these two, I run it on the browser, I perform the clicks, and I open the profiling tab in the developer tools. By the way, if you tried the profiling tab, you should. It's helped you a lot for giving you a lot of information, insight about the applications and about re-render and everything. So which one of these two is the performance profiling for useMemo? In the case we implement the useMemo. Number one, raise your hand if you think it's number one. Number two, the bottom one. Yeah, you are very correct. So it's the second one, the bottom one. But you can see here the chance is not so much different, likely different between these two. Okay, so I decided to do another test. This time I increased the size of the array to be 1,000 items. And again, same quiz. Which one you think here is the performance for the case where we implement with useMemo? The top one? Okay, the bottom one? You're correct. Good for you. So the second one is actually the performance result for useMemo. And you can see here the change in about from 9.6 milliseconds to 9.5 milliseconds between these two. Still, it's not a lot, right? And at some point, the first approach is a bit faster than the second approach. But pay attention, because I'm going to ask another quiz in the later slide. Okay. So I went to the documentations to understand what does it means by expensive calculation according to the React team. So in the official documentation, they say that in general, unless you're creating or looping over 1,000 objects, it's probably not expensive. Again, it's probably not expensive. It's not a deterministic answer. It's maybe not. Probably not. And it say over 1,000 objects, then you should think about it. But again, you can see that in our demo, we only render a list of items which each item only have a title and some text. Though it's not a lot. Maybe it would be much different if we render a component. The list item is more, let's say, more complex. Then maybe the performance will be more significant. But then, again, then how do I define whether or not it's probably the case that I should use useMemo? So I decided to do another test, this time with the timer according to the official recommendations from the React team. I had a timer in the front and the bar top, and the timer at the bottom of the calculations. And we'll see how that before and ending of the time to see what the difference between the timing. And I performed the same test. So also according to documentations, they say that if the log time, the overall log time is more than 1 millisecond, then it might make sense. Still, it might. It doesn't mean that it's 400% makes sense to memorize that calculation. It just says that if it's more than 1 millisecond, you probably should consider memorize that calculations. So let's try to look at our result for our test on 1,000 items we render. So you can see here, between these two, no memo, and with we use memo. So the change here is not even reached to 1 millisecond. So is it worth it or not? Well, I let you decide on that. But there's something else that caught my eyes here. Can you find it? So for the first two renders, you can see the huge difference. So for the non-memorizations, the first render kind of static, like 3 milliseconds, 2 milliseconds, and so on. But for the one that you use Memo to optimize the memorizations, the first two render, it reached to a 13 millisecond or 15 millisecond. That's insane, like the amount is too big compared to the non-Memo. So this is the case where you start to realize that useMemo is not the same with fast first render. So what actually happened in the first render? So when we use useMemo, in the first render, React will define the dependency when it reaches to the code block that wrapped by useMemo. And then it will try to trigger the function to do the calculations and calculate the return value. And then it allocates memory to catch the return value for the next time. So if in the next render, nothing changed, it will use the catch version. If something changed, these two trigger the function again and catch the return value again will happen. And that's come another question. What happened to the catch value? What are we going to do with that? You may argue with me that JavaScript, we work with JavaScript, we don't care about garbage collector on the old cache because it has its own garbage collector. But you need to know where this old cache goes. Does React dump it somewhere? Or does it keep it for the next time when it sees that something is similar and it doesn't need to recalculate? Well, we never know. It's garbage collector here is an issue, right? So with useMemo, does it worth it to use it and go on the way here? Let's say if the first time you do a lot of heavy calculations, then your component will render very slow still. And you know in web applications, the first experience is always important. So whether it's worth it or not, well, you think it for yourself. So the next, now we're going to move to the next hook. It's useCallback. So for useCallback, it's similar to useMemo, except that it's the React hook that only catch the function definition, not function return value between renders. The syntax is similar, and you wrap it with useCallback and put the dependency. And it will help you to skip the re-render, same like useMemo. And it's used for optimized custom hook. So what is optimization of custom hook? Again, it's straight from the documentation, no explanation further. What do you mean by optimized custom hook? So we take a look further. So in the documentation, it says useCallback still doesn't prevent creating functions, which means if you have an inline functions inside the component, JavaScript engine will still create the functions, but React ignore it and give you back the catch version if nothing changed. So what happened in the first render or the render cycle? In the first render, it see that it have useCallback. It will define the dependency, and then it would create the function definitions with on the value of the dependency at that point, and then it will allocate memories to catch this function definitions, and when the next, and then the user, then the component can use this catch version. So the next time when it's rendered, if something have changed to the dependency, it will trigger this allocate memory to each function definition again. And then when the function is triggered, React will use the cache, the latest cache version instead. Now here comes the question. If React ignore on this function creation, right? So what will happen with on the creation, on the created versions of the functions done by the browser? You may say that it's already get collected by the garbage collector. But again, where's the garbage collector on the cache version? What happened to the version that was one step older than the current version? Well, according to React team, they're not doing anything with it. So they just leave it there, which also means that you will end up with a lot of old cache version if the function invalidates very often, and it's not efficient for resource allocations in long term. So if you're using useCallback, if you're using no useCallback, you have garbage collector go from default from a browser from JavaScript. If you're using useCallback, you probably don't have any automatic garbage collector unless the React team implemented in later version, but you will never know what happened there. Okay? So let's come to the next question. I like to ask questions here. In this code, how many times on favorites will be invalidated, which means a new version will be created and catch? Well, you can see here that on favorite, it actually calls set favorite, and it uses favorite items, which is the local state, and it set favorite if you found it, then you have to remove it from the favorite list, or add in a new item to the list. And the favorite item is the only dependency. So which means if user click on favorite an item, it actually triggers this function, and this function is updating the favorite items, and then the favorite item change, which means this function will be recalculated, and it's like a loop all the time, a very frequent, and on favorite is the very frequent user interactions. So which means in this one, the number of catch versions for on favorite will be a lot, because it's invalidated all the time, because it's part of one of the dependency. You set the dependency inside your own function. Why you depend on that? It's kind of feel like recursive a bit, no? So for that, when you use callback here, it doesn't make sense anymore. So how do we solve it? Well, there's way to solve this problem. First of all, you can pass it at an empty array. So we don't have anything dependence, which means it will only catch once in the beginning, in the first render. And instead of using the favorite item directly in the component, you pass it to the set state at a functions instead of the object. This will help React to avoid multiple trigger of set favorite. It will only update in patch once with the latest value of favorite, and the function still don't have to rely on the local state dependency. And this will solve the problem. Great, right? So now we can use callback and we can avoid the invalidate problem. But then let's see what other potential problem we have here. So in this code, I'm going to console log the current value of count. So what is the output value for count for every time when I increment the count value? Anyone say 1? Anyone say 0? Well, the thing is, why the actual value of the local state count always change correctly and always update correctly, the console log will always stay at 0, because these functions only catch 1, and it's catch at the value of count at 0. So when you use this approach, you need to make sure that you don't use any local variable, local state that change, because it will not be recatch. And this is hidden bugs here. Like, you actually have to be careful if you have a very long component and add in some more feature inside. So that's one thing. The next thing, the next quiz. Okay, in this code, how many times useEffect is triggered? In this approach, in this implementation, I have a local state on DB, setDB, which is the database. And I have a function that do some on-save saving and set the DB. And the DB also can be set outside of this function. And this function is the dependency for useEffect, which means whenever this function change, I will trigger this useEffect and trigger the on-save function. Okay, so the right answer to this is that every single time when on-save change, useEffect will be triggered, right? But how many times on save change? On render. On every single render, regardless whether the DB changes, as long as you have other local state change, the component re-render, rerun the logic, then the onsave will be recreated because create a new function definition. And because we don't use callback, so here the useEffect will keep triggering again and again, and we may end up with performance problem here. So here comes, when are we going to use callback? So the first thing, first and foremost, is the hooks that meant to use to wrap around the functions that will be passed to a memorized component as the prop. The memorized component is the component that wrapped with React.memo. This is to make sure that we optimize both optimize the memorization of both the function and both the component, and avoid any more leaking, performance leaking. The second scenario is when we use this function as a dependency on another hook. It's not to optimize another custom hook, it's to make sure that we don't make the hook trigger more than it should be, like useEffect. And lastly, when you just don't care, like, you know, people are always like that. I mean, after I give this talk so many times, in my team, people still do to wrap with useCallback because the very valid argument is that better safe than sorry, and I don't have time to dig in, I don't know what's going on in the futures. Or I don't care about readability and other overhead. So this is only the 3 cases that you should consider useCallback. And lastly, you may not need memorization at all. Of all of these, you can see useMemo for over 1,000 items you may need. But again, you also saw the comparison between 1,000 items, and it not even reached to 1 millisecond to do memorizations. You may need memorization in a case where you do a lot of heavy calculation, like providing calculate the coordinates of a map, an interactive map, or providing transitions, or listening to some native event of the DOM or of the browser. So this is the case that I saw that may need memorizations because it's very complex calculation right there. But otherwise, if you do a very simple function, very simple list items or render components with the text, just don't need memorization because you probably is not free. Also, there's another way, there's another problem here. Even if you use memorizations, let's take a look at React render cycle flow. So I have a parent and I have a modal and children. So I have a modal so that on the children, when they click open the modal, it will only open one modal, and I don't want to add the modal to every children or descendant, right? So I passed the functions. I passed eopen, set eopen modal, which is the change in the state here, to the children, and the children would trigger the modal by open modal, something like that. Okay, so now if is open modal change, which is someone or even the parent doing it, what happened here is both parent, modal, and child are re-rendered because it's when it is the local state of the parent. When the local state change, the parent change. The parent change, the child also change. Waterfall rendering, or we can call it live up state problem. And in this case, even if you do use callback or memorizations, it doesn't work. It doesn't help any case because the problem lies on your code structure here. It's not a lie on the way you use the hook. It lies on the way you actually arrange the whole data structure of your applications. So things we can do before we start thinking about memorization or performance optimization. Number 1, don't leave up state. If you have a shared common state between these two components under same parent or very same ancestor, don't leave up the state to the ancestor. Just maybe use context or maybe trying to share the common hooks only with these two components, okay? And avoid that. Second thing is minimize the dependency list. My rule of thumb rule of thumbs is if you have more than 3 dependents in a dependency list, you probably don't need to wrap it with your dependency list. You don't need the memoization, because if you have 3 or 4, the chance is that your function will be invalidated very often, because at least you have 4 variables here that keep watching. But again, even if with only 1 or 2, you still need to plan and validate your code structure very carefully. So in this case, I only have 2 dependencies, eArrow and task. But if you pay attention here, that task and eArrows are not going to be like so much like different, like on the same page or something. So when you have task, each arrow will always be false. When the arrow is true, then you shouldn't have any task. So is there a point to put these two in the same dependency list when you don't need to watch for both? You only need to watch for one. So I leave that question for you when you plan your code. And don't use useCallback with internal or lowest level functions. What does that mean? If you write a component like wrapper around an input like a very lowest level, you write in a component library, and it's used to render a DOM element input, and then you have an on-chain function. Don't wrap this on-chain handler with useCallback, because it's not needed. And this function, if you wrap it with useCallback, anything that passes to this component have to be wrapped with useCallback also. And somewhere along the way, if somewhere on the top, someone forgot to use callback, you will have a bug. We have this before in our code, and debugging it is very terrible, because we don't know where it stopped updating the value we pass into the function. And lastly, don't jump to the new shiny hooks. I saw so many blog posts before React 18 official launch talking about use event callback or use event hooks. In the end, this hook doesn't make it to productions. But again, they say that this hook will be better instead of use callback, will solve the problem of optimizations, of performance, and so on. It's not. It's not a problem with the hooks. It's the problem with the one who used the hook. The shiny hook will look shiny and interesting, but it doesn't mean that it will solve your problem. You will still have the same problem in a different scenario, like this. Don't use this. You use memo on review dislike and review like, and then return a text. Do you really need this? I found it on Twitter a couple years ago, and still arguing about whether it's good or not, but for me, it's like, no, please don't do this. It's just not really working. And lastly, everything has a trade-off. Like I said, memorization is not free. And everything you do, you will have to trade off whether or not the performance in another aspect or your own readability and maintenance ability for your team. And that's it. Thank you for joining my talk. Hey. Yeah, I make this. Okay, so any question on the thing?
Talking about the state management, are there any weaknesses on performance about the use context?
Well, yes, it is. There's several performance issues with use context. And one of the things is, I don't remember exactly what, but the problem is still, when you use context, you still have the issue with re-render. And also that, like, you need to, how to say it, when you wrap it, when you use context in one, you still need to wrap the parents with the context provider component. And if you're not careful, then the parents will also re-render, because the context provider also re-render in some case. And one of the cases I found that's interesting lately, we were working with some new products, and we actually developed a React application as extension for this the big applications in this product. And this product have a mechanism to catch the whole extensions and the page that render by our applications. And it caused the fact that even if we have a use context in an application is supposed to re-render whenever you move to the page, to the different page and go back. It doesn't. It just use the same context, the same value, but it's shared between the different page, and it's caused us a lot of headache. It's very hard to explain to you the problem we have with use context lately, but it's almost any hooks in React. If you're not careful, you will end up with performance issue. So I hope it's answered your question. Okay. Any other question?
Yeah, so this is also valid, for instance, also for hooks like useSelector, about the refreshing of the values of the component.
useSelector?
Yeah.
I never tried that one. Is it valid? Is it a hook in React?
I think it is provided bounded with React Redux.
I don't. I mean, I never use it, so I cannot comment on that. Maybe. Yeah. Sorry. Okay. Any other questions? I mean, if it's the hooks that is not from React library, then it's likely that I never use it. Okay, that's it. No more questions? Okay. So if you have any question, I'm here. Just approach me. I'm still, again, I'm always debate with myself on this everyday basic. So not all the things here are, I would say, single sort of true. Like it's not like what I say is 100% correct and 100% like you can always argue with me. Like I always argue with my, like not argue, we call it discuss with my teammates during the development itself. Yeah. Thank you very much for joining my talk.